We're going to use Matlab to solve first-order differential equation to use the solvers. We're going to use the solvers in Matlab. Matlab has some built-in solvers, and we're going to use those. And so let's start, again, we're going to start with a single differential equation. So let's say if we start with this differential equation right here, and then we have initial condition, and we're asked to find the solution over the interval t equals 0 to t equal 4. So again, we're going to do this in MATLAB. A couple of things we have to do. First of all, we're going to have to rename our dependent variable. So we're going to rename y to y1. Now, if we had more dependent variables, the next one will be y2. If we had another y3, but we only have one dependent variable, we're going to rename this y1. And don't get confused here. This is not like an index like we do with iterations and stuff. We're just going to name this y1 like this. So that's the first thing we're going to do. Next thing, we're going to write the function. Write the function for the differential equation, for the ordinary differential equation in MATLAB. And so let's go ahead and do that. So our function will look something like this. And now the function is going to go at the end of our code, but I'm just going to write it here. I'll write it like, say, towards the middle of the paper. So let me write this function. And it's always going to take this form. It's always going to start with function, and then it'll have an end. Again, this is going to be the routine that has the differential equation. And up here at the top, it's always going to be dy equal. And then right here, you're going to give it the name of whatever you're naming the differential equation. I'm going to call it EQN1 and put the independent variable and the dependent variable like that. And so that's kind of the skeleton of it. And again, this is always going to be the same. The only thing that's going to change is the name that you're given the differential equation. Then the other thing is we're going to have to right here do dy equals zeros and 1, 1. Now right here, this first number is always based on the number of dependent variables. As I mentioned, in our case, we only have one. We have y. And so if we had more, if there were 2, this would be 2. If there are 3, this would be 3. Now, for our purposes, the second entry is always going to be 1. And we can put like a semicolon here so to suppress the output. Then write the differential equation. Once again, keeping in mind we have renamed y to y1, and that's on the left and right hand side. Now on the left hand side, instead of having y prime, we're going to have dy. So we're going to put dy there, and it'll be dy1, and then write your differential equation, negative t times y, but now that's going to be y1, then plus cos of 2t, which is 2 times t, like this. Then again, suppress the output by putting a semicolon. You don't have to do this, but I usually do it to suppress the output. So this is our routine. This is our function for our differential equation. And now we're going to write the basic code itself. And so let's go back up at the top of the page. So now we're going to call this differential equation. And we're going to solve it. So back up here early in the code, put the square brackets with t and y like this. And I'm going to use the solver ODE 45. And there's lots of solvers in Matlab. I'm going to use this one. Later on, we can get into what the difference is between them. So again, this is the solver, and you put a parentheses, and then you put at, and put the equation name. I called it EQN1. And now over here will be the span over which you want to solve it. Like in our case, it's going to be 0 to 4. So we could put 0 to 4 here in square brackets. And then the next entry is going to be the initial condition, or the starting point. So again, this is going to be like the interval over which you're solving. And this is the initial point here. Now, rather than put them directly in, well, I'm going to give them names. I call this T-span. That way we can easily change them. And then over here, just going to call this Y0, like this. And then so up above here, I'm going to put those values in. And we said that we wanted the solution from t equals 0 to t equals 4. So we're going to use what we call time span here, T-span, and then equal. Again, this is going to be square brackets again, 0, 4, no commas. Just put 0, 4 like this. And again, put a semicolon to suppress the output. And then we want our initial condition, and according to our problem, our initial condition was -3. So we're going to make Y0 equal -3. Now, what I'm naming these like here, those are completely arbitrary. So you could put the time span directly in here. You could put the initial condition directly in here. But sometimes I find it easier to do this way, because then I can use the same code for a different differential equation. Now, believe it or not, we're almost there. The final part is to plot it. So right after here, plot ty. And that's all we need right there to solve our differential equation using the solver in Matlab. So let's go through this here. We assigning a time span, 0 to 4 seconds, initial condition, -3. We're going to call our solver. And again, you have to, left-hand side, you have to put the independent variable and the dependent variable in this order, square brackets. Call this solver ODE 45. And again, what do we want to solve? We want to solve this equation 1, which is defined down here. So when it sees this, it'll go looking for this function here to solve this equation. And it's going to solve it over this span 0 to 4. And with this initial condition. And then it's going to plot the solution. So let's go ahead and do that in MATLAB. And so I put the code in just the way we talked about. The only thing is I put this clear all at the top. Again, if you have other variables in your MATLAB environment you want to keep, don't put the clear all in. but I often put it in just to be sure there's nothing extraneous that'll get pulled into MATLAB. So I wrote everything down as we said. I did put some uh, comments. Remember the percent sign. After the percent sign, you write comments, which I did here. And I did the plot. One other thing I had, I put the grid on so we have a grid. And I also labeled the axis as the x-axis and the y-axis. And then down here was the function that we talked about. And so now let's go ahead and run this. As usual, be sure when you're up at the top here, be sure you're in editor and then you can find your arrow to run this here. And then when we plot this, then we run the code, we get this curve right here. And as you can see here, it started at time equals 0. Remember, our initial condition was -3 down in the left corner. And then it solved it from 0 to 4. It put in these axes here. And like I said, sometimes I like to add things. I'm going to make these axes more bold and a bigger font. So let me go ahead and go in and do that. And so I'm going to make the font size bigger. And so we can add these lines down here. Now I'm also going to put a title on it. Here I'll put a title, Differential Equation Solution using MATLAB. And actually, I'm not going to need this right here. Let me take that off because I'm going to get that from below. So I'm putting the title name in quotes. I have differential equation solution using MATLAB. Then down here for the axis, I have AX equal GCA. And I want to change the font size of my plot. So I'm going to make it 14, a little bit bigger font. And then I'm going to change the weight to bold. So I'll put that in. And we'll run this again. Once again, go up here at the top where it says editor and push run. And there's our plot. Everything's the same as the last plot, except everything's now in a bigger font. And everything is in bold letters. So that's how you solve a differential equation in MATLAB using their solvers. Again, there are other solvers you can use. I use this ODE 45 and many others you can choose from. And the next thing we'll do, we'll look at solving a system of differential equations in MATLAB.